Alright, so this is what my presentation is going to be over. I'm drawing the Earth's orbit. So we got the winter side, the perihelion at 91 million miles. And we got the summer side at 94 million miles. And that's actually the size of the sun, which is 865 million miles, or 865,000 miles. The diameter of it, little bitty thing compared to the orbit. So the orbit circumference is 584 million miles with the eccentricity of 0.01671022. And so I'll get into it. So in this video, I'm going to draw the Perihelion, the Aphelion for the Earth's orbit. I should do it each year, but sometimes I tend to slack off and don't draw it every year. So I'll just show you how I do it for 2023. So I go to time and date. It gives you the times and dates and the distance, but I don't use these distances. I use this NASA website to get my distances. It's more accurate. So here's the sun. That's the target. The observer location is geocentric, is the center of the Earth. And then I can put in my times. And then you can edit. I want 4, 20, and 28. And then I come down here and put it to kilometers. Use that. And so we'll go ahead and we'll start for the July. So it's at 3:06. So first I need to know what 3:06 is in UTC time. So 3:06 minus 1 hour is 20:06. So 3:06, which is 2, and then 20:06. Alright, so then I got my time. So I come to this horizon thing and I put in so July 6th. So I want the whole complete day. So I go 5 on the 5th and the 7th, increments of 1 minute. And then I've already generated it. So then I come down here and find July 6th at 20:06. And you'll notice, you'll just notice when I get there. So 20:06, whoops, July 6th. $20.06. Where is it? All right. 20:06. All right. So is how I can tell is there's a negative 0.000015, and then here there is no negative, so I know I'm at the right spot. Okay, between those two, because these are all negative and these are all positive. All right, so I'm going to go ahead and go with the 20:06. So I'm going to get that distance, which is in kilometers, and then I'm going to convert it to feet. Copy. Go into CAD. So this is normally what I have, but it's good, but it's not exactly. So, and I'm drawing the July 4th or 6th, so I'm drawing that side. So paste. Enter. Okay, so let's check this distance. See how close they were. So I got 94.5. What did they say? 94.506. 506. See, I got three. They got 364, 506, and I got 07. Now I'm going to go with NASA. So that's what I'm going with. All right. So now I need to draw the other side. So I need to find out for January 4th at 10:17 a.m. So UTC time. So at 10:17 a.m. So 10:17, which is 16:17. So come back over here. I need to change my date. So that's 1 January. And that's the 4th. So I want to go 3. And I want to go 5. And use, and everything's correct. Generate. Alright, so now scroll down here to January 4th at 16:17. And you'll notice the same thing. There's a negative, and then all the rest of them here are positive. The last one I used, it was a 0. I don't know which one I should use. I just go with 17 because that's what they asked for at the time. So I'm going to use this distance. And they're pretty much the same. Alright, so copy, convert, paste, copy, AutoCAD. So I got that line. Now I need to draw this way. Paste. Rotate. Whoops. Alright, so that's the orbit. And that's the center. So now I need to draw the ellipse. Alright, so to do that, I need the, let's see here, the orbital eccentricity. Alright, so it's not a complete circle. So if I did a 1, then it would be a complete circle. So I need I thought it was 0.167. I don't know where I got that from. Anyways, copy. Orbital, yeah, so, alright, so CAD, ellipse. So I'm going to go here to here. I'm going to hit this rotation. Alright, so I noticed my video kind of cut off a little bit too short as when I was drawing the circle. Anyway, so the eccentricity, 0.0167, copy that to my drawing, erase, ellipse. So you hit here to here, and you'll notice if you rotate it, goes in different directions. So rotation, paste, and that's what it is.